Good day, students. Welcome to mathgotserved.com, and in this clip we're going to be going over how to carry out operations on functions. The instructions are as follows. For f of x equals x squared minus 4 and g of x equals 2x minus 4, the task is to find f plus g of x, f minus g of x, f times g of x, f over g of x, and f composed with g of x. Alright, so let's go ahead and start with the first one. So for the first part, we're to find f plus g of x. Okay, so what is f plus g of x equal to? F plus g of x is equivalent to f of x plus g of x. Okay, so what we're going to do is we're going to substitute f of x, which is x squared minus 4, and g of x, which is 2x minus 4, into this equation and simplify. Alright, so f of x is x squared minus 4 plus g of x, which is 2x minus 4. Alright, so the question is as follows. Since we're adding these two functions, is it necessary for us to use a parenthesis to separate these two functions? And the answer is no. When you're adding functions, you do not need a parenthesis. Okay, so what we're going to do now is combine like terms where possible. We have x squared. The second degree term has no like terms to be combined with, so bring it down. Same with the first degree term, which is 2x, but we have two like terms, minus 4 and minus 4. These are constants, so we can combine them to yield negative 8 minus 8. Alright, so the sum f plus g of x is equal to x squared plus 2x minus 8. Alright, let's move ahead to the next operation we have to carry out, which is the subtraction operation. So let's say we are to find f minus g of x. So what is f minus g of x? F minus g of x is simply f of x minus g of x. Okay, so the next step is equivalent to what we did in the first problem, the sum, where we're going to substitute f of x and g of x. Okay, so for f of x, we're going to put in x squared minus 4, and then for g of x, we're going to put in 2x minus 4. Okay, now take a look at this expression. Is this correct? The answer is no. What's the problem here? Whenever you're subtracting functions, you have to put a parenthesis after the function that goes after the minus. Okay, because this minus is going to affect the signs of every single term in the second function. Okay, when you're adding, there's no need for parentheses, but when you're subtracting, the quantity that comes after the minus must be grouped in its own parentheses in order to avoid making sign errors. Okay, alright, so we're going to bring down the first function, x squared minus 4. What's happening here is that we have an invisible coefficient, namely negative 1. So what are we going to do with this negative 1? We are going to distribute it to the two terms of g, namely 2x and negative 4. When we carry out that distribution, we're going to have minus 2x plus 4. So you see the importance of having that parenthesis. It helps you remember to distribute and effect the necessary sign changes of the terms. To finish this off, we're going to combine like terms. X squared has nothing to combine with. This first degree term 2x minus 2x has nothing to combine with also. but we have two constants here. Negative 4 plus 4, these are both constants. If we combine these two like terms, they add up to 0. So our final answer is x squared minus 2x. Alright, let's move on to the next one. We're going to carry out the product next. So we have, for the third one, let's change the color. What if we want to figure out what f times g of x is? F times g of x is equal to f of x times g of x. Okay, so let's go ahead and substitute what these two are. So f of x is x squared minus 4, and g of x is 2x minus 4. Notice that for the product of two functions, we grouped both functions in the parentheses, okay, because we're going to have to distribute the terms across one another. So in a multiplication case, both functions have to be in parentheses. In the subtraction case, only the one after the minus, and then in the addition case, you don't have to have any parentheses there. Alright, so we're going to expand this. We're going to use the FOIL method. So you have first, outer, inner, last. You can use this method, you can use the box method, whatever makes you happy. Just remember how to multiply two binomials, okay? So x squared times 2x is 2x to the third. X squared times 4 is minus 4x squared. Negative 4x times 2x is negative 8x. And then minus 4 times minus 4 is plus 16. Okay? Like terms that could be combined. There are no like terms to be combined here. So ladies and gentlemen, this is the final answer for the product f times g of x. Alright, let's go ahead and take a look at part 4, namely the quotient, f over g of x. F over g of x is equal to f of x divided by g of x. Alrighty, that's what it is. So let's carry out the substitution. F of x is x squared minus 4, and g of x is 2x minus 4. Now, is there a common factor between the numerator and the denominator binomial expressions? It's hard to tell if they are common factors if they're in their expanded state. We have to factor them completely, and then we will be able to tell if they have factors that are in common. Okay? So what we're going to do next is we're going to extract the numerator quadratic binomial, and we're going to factor it. Okay, so let's go ahead and factor x squared minus 4. X squared minus 4 is a difference of squares. Okay, there's a formula for factoring difference of squares. A squared minus b squared factors into a plus b times a minus b. So what you're doing in essence is finding the sum and difference of the square roots of the squares. So you root the first term and the second term and express the roots as a sum and a difference. Okay, so we're going to apply the same procedure here in the factorization of x squared minus 4. What we're going to do is we're going to root the first and second terms and then express the roots as sums, as a sum and a difference. Okay, so when we do that, we're going to end up with the square root of x squared is x, so x plus 2, which is the square root of 4, times x minus 2. That's a factorization of x squared minus 4. We're going to go ahead and insert that back into the problem. So we now have x squared minus 4 becomes the factored state x plus 2 times x minus 2. Now if you look at the denominator, we have 2x minus 4. There's a greatest common factor that can be pulled out here, and that is 2. So we factor out 2, we have x minus 2. Remember, anytime you factor out a greatest common factor, is as though you're dividing the terms by the factor that you factored out. Alright? Now we have like terms in the numerator and the denominator, namely the x minus 2 quantities. So we divide that out in the numerator and the denominator, and we end up with x plus 2 divided by 2. Okay? Since we have a variable in the denominator of the original expression, namely 2x minus 4, what we must do is we have to specify the restrictions on the domain of this quotient. Alright, so let's go ahead and find the restrictions. To find the restrictions on the domain of this rational, all we do is we set the denominator to a value that's not equal to 0. So the denominator can never be 0. Okay? So the denominator in this particular problem is 2x minus 4, and this can never be 0. To solve this, to find the restriction, we will add 4 to both sides and divide by 2, which will give us 2. Okay? So you add 4 to both sides, you have 2x cannot be 4, and then divide both sides by 2. And you see the restriction is that x cannot be 2. Okay, so let's apply that to our final answer. We have x plus 2 over 2, and x cannot be 2. Okay, and x cannot be 2. That's the restriction on the domain, ladies and gentlemen. That is the final answer for the fourth part, the quotient of f and g. Alright, the next thing we're going to look at, the last part, is the composition operation. So for part 5, we want to find f composed with g of x. Okay? So f composed with g of x is simply f of g of x. Alright? So we have the outer and the inner function. The one that comes first is the parent or outer function, and the one on the inside is the inner function. Alrighty, so to carry out the composition, we'll start out by writing down the parent function, which is the one that comes first. In this case is x squared minus 4. And then let's write down the inner function, okay, which is g of x, and that is 2x minus 4. Now for the composition, what we are going to be doing is we're going to be taking the 2x, and we're going to 2x minus 4, and then we're going to be substituting it for the x's in f of x, so namely this x right here. Okay, so to do that, the first step will be to get f of x prepped for the inner function. To get f of x prepped for composition, what we'll do is remove the x's in f of x. Alright, on the left side we're going to input the name of the inner function, and the value of the inner function goes on the right side. So the name of the inner function is g of x, and the value is 2x minus 4. Let's go ahead and simplify this, okay, and that will be our final answer. So f of g of x is 2x minus 4 squared. Just simply means we're going to be multiplying 2x minus 4 by itself twice, and then we'll subtract 4. Okay, so we are multiplying binomials here again, so we're going to double distribute or FOIL. So first outer, inner, and then last. Alright, let's go ahead and multiply. Well, we'll multiply f of g of x is going to be, so 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Negative 4 times 2x is negative 8x. Minus 4 times minus 4 is positive 16 minus 4. Okay, we're going to combine like terms to generate our final answer. 4x squared has no like terms to be combined with. We can combine negative 8x and negative 8x. Those two add up to give us minus 16x. And then lastly, we have positive 16 minus 4. Okay, so positive 16 minus 4 is going to give us plus 12. Subtract and keep the sign of the bigger, which is positive, and that's the final answer for the composition operation, f composed with g of x. Alright, so this is basically how you compose functions. We have how you carry out operations on functions. So we have a question for you. Take a look at these 5 operations: addition, subtraction, multiplication, division, and composition. Which of them do you find to be most complicated or involved? Would like to know? Just post your response in the comment section below and tell us why you find that particular operation complicated. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of operations and functions, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about this presentation, or you would like us to make a particular math video, include your comments or requests in the comment section below, and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to other presentations such as this. More support resources can be found at our website, mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.